most exciting moment of coding in this game is to check the condition of game over, right? Okay, so let's talk about that. So one strategy is we can check every piece in our pieces box, right? And to see if we have a connection of 4 pieces in a row, horizontally or vertically or diagonally. But think about that. Actually, the game over only happens after we make the last move, right? Because when the game is over, we cannot drop any more piece. So it means we only need to check the last one we dropped at, right? We don't need to check every one inside this pieces box. So it will save a lot of trouble and effort. Okay, now let's bring up our blackboard. So say we already have 3 yellow pieces floating on the top of any column, right? Then if we drop another one here, then we win, right? This one. Go back to Xcode to implement it. Okay, Xcode. So, function game over at a column, right? Column, yeah. Return boolean. Game over. Is game over or not? Let's silence the compiler for now using a fake code. Okay. So now, what's the strategy? We'll check this scenario first, right? And let's find the top. Let's find a top of like this very column. So that top equals what? We know the number of pieces at this column. For example, 4 here, right? Then what is the top? Top is 0, 1, 2, right? 2. Okay. 0, 1, 2. Okay, so it means this one will be 6 minus 4, right? What is 6? Connection 4. Connect4 game dot rows. That's 6, right? Minus that number. So this will be 2. This is the top row here. We'll check the 3 pieces starting from top and going down below it. Okay, so 4 I in 0 dot dot, that's then 3, right? So the first one is this guy, the top one. So let's find out the piece. So let piece equal to piece at column, yeah, this column, and the row. What is the row? The row will be top plus I, right? Yeah. But this piece can be nil, right? It might be empty. So what does it mean if this piece is nil? It means, for example, if we drop a piece here, right? Yeah, say this column is empty, so the top will be 0, 1, 2, 3, 4, 5. It will be 6. So we're outside the board. So that means, of course, game over is false. So we can do something like that using a syntax specific to Swift. So if that, it means in this block, it means piece is not nil. So else we can return false, right? Game is not when it's not over. Game is not over. So now here we know piece, this guy is not nil. Now in this block we can compare the piece color with whose turn. If piece dot is red, is equal to is yellow's turn. It means it's a different color, right? It's red, but it's yellow's turn. So it means we can return false. Here. Otherwise, we'll continue to check, right? To continue to check the next one. So if we never return false, it means here we can return true. Right? It means after we check 3 of them, all of them has the same color as whose turn. Let's give it a try. Run it. Oh, we didn't call this one. So somewhere we need to call this one. Okay, so we can do drop at. Let's test it on here. View controller. So when we make a move, right? If drop at that, okay, so we'll check. Let's print out the game over. Okay, print out game over at colon. Yeah, so run it. Let's clear this annoying message coming from the AV player, audio player. Okay, let's try this one. False, 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 false. Okay, now let's try some true thing. One. Let's put the yellow here, red here, yellow here, red here. Now, the next one should be true, right? Oh, there's a bug. Another one. What's wrong here? The reason is our logic is based on the moment before we actually make the last move. So it means we should check this guy before we make the move. So let's do it here and run again. Okay, let's clear this console and try it again. Red, yellow, red, yellow, red. Now next one, be careful. Yellow, true, you see? Game over. Yes, it works. So it means the logic here works. Okay, in our next video, we'll talk about how to check the other scenarios, right? Like horizontally connected for, or diagonally connected for, right? This way and that way, right? See you then.